So we're going to analyze a radical function in this problem. So let's go ahead and read the situation here. It says the Rainbow Bridge is about 54 meters above the water. The velocity v of a freely falling object that has fallen h meters is given by v equals the square root of 2gh, where g is the constant 9.8 meters per second squared. Graph the function. If an object is dropped from the bridge, what is its velocity when it hits the water? So the first thing that we're going to do is to graph the function. Now the function as it's written has three variables in it, v, g, and h, which of course means we cannot graph it using a standard graphing calculator. However, the problem does tell us that the value of g is 9.8 meters per second, and that it is a constant, 9.8 meters per second squared. So whenever we write the equation, we can write it as v equals the square root of 2 times g, 9.8, times h. So we can put it in as 2 times 9.8 times h, and now we only have two variables. So because graphing in a graphing calculator typically uses y and x, whenever I put this into the grapher, instead of using v and h, I'm going to use y and x. So I'm going to use y equals the square root of, and then 2 multiplied by 9.8 is going to give me 19.6. So I'm going to do 19.6, and then instead of h, I'm going to use x. So even though I'm switching the variables, v is now going to be y, which is still going to be velocity. And then I changed h to be the variable x, but that is still going to be its height in meters. So even though I changed the variable to be x and y for purposes of graphing, they still mean velocity and height. So now I'm going to use Desmos to graph this. So I'm going to come over here and do y equals the square root of 19.6x. And so this is what the graph looks like. I'm going to actually zoom out a little bit. I want to go all the way up to a where I can see the h of 54, because it says that the height of the bridge is about 54 meters above the water. So I want to go out to where the height is 54. Height I graphed as x. So I want to zoom out until I can see an x of about 54. Okay, there we go. So now in between the 40 and 60 there is approximately my x value of 54. And it looks like a reasonable guess for a y value would be, looks like almost exactly in between 20 and 40. So I'm guessing like around 30-ish is going to be the correct y value for a height of 54. Now, rather than just saying 30-ish, we can figure out exactly what that y value is by going back to our function and replacing the h with this value of 54, which is where the object would be dropped from, since the bridge is 54 feet above the water. So let's go back to our original variables of v and h. V equals the square root of 19.6, and now instead of h or x, I'm going to use 54. So 19.6 multiplied by 54. And I can use Desmos for this as well. 19.6 times 54 times 54 is 1058.4. So the square root of 1058.4 is going to be my solution. That'll be the velocity. And what is the square root of 1058.4? Well, let's put that in next. 1058.4 is about 32.533. So we'll say the velocity is approximately, let's just go ahead and round this to the nearest tenth, 32.5. And the unit, since we were measuring in meters per second, it's going to be 32.5 meters per second. And that is how fast the object will be going when it hits the water if I drop it from a height of 54 meters above the water.